Hi once again, everyone. Welcome to my channel. And today we will see the refraction through prism. First, I would like to tell you what is a prism. See, a structure, a transparent structure made like this is known as prism. This structure is having a triangular cross section, as you all can see. This surface, this front surface is looking like a triangle. ABC. This is a triangular cross section, and the surface is also having a rectangular faces. A, B, D, and E is the rectangular face. And if I'll say this one as F, then AEFC is also a rectangular face. And considering BCDF, that is also a rectangular face. Whenever a ray of light falls on this type of a structure, that is a prism, it will suffer, it will go through a refraction, which is from this surface AEFC, and it will come out of this structure from face ABDE or CFDB. If I have considered this FCBD as base, then it will use these two surfaces, this one and this one, for the phenomena of refraction. And this line AE is known as refracting edge, and rest you can see from the diagram. So we have to study about the refraction through prism. For that, I have to draw a triangle again, the triangular edge. So in the next slide, we will draw the triangular edge. Okay. See, I have considered this triangular edge. Now I have to take a ray of light. The ray of light should be somewhat like this. Somewhat like this. Okay, sorry. It is moving its thickness. Somewhat like this. Okay. Now see, we know that if this medium is rarer, this medium is rarer, right? In the medium which from where the ray of light is coming is rarer. So from rarer to denser, when it will the ray of light will travel from rarer to denser, it will go on refraction. That is, it will bend towards the normal. Let's say consider this is a normal at this point. Let's say this is a normal at this point. This is a normal at this point. Okay. Now, if I'll again consider this white ray of light, it will bend towards the normal. That is like this. Okay. It will be like somewhat like this. If you will say that the angle, if I say this one as angle I, this one as angle I, then this one will be angle R1. Or you can say it as R only or R1. Okay. Now you can clearly see that angle I is greater than R, that R1. That simply means that it is going from rarer to denser medium. Now, after traveling from rarer to denser medium, this ray of light again travel from denser to rarer medium. Again, it will follow the refraction phenomena. For that, again, I have to draw a normal at this face. It will be something like this. Okay, like this one. Okay. Now, let me make it. Okay, now it is normal. Okay. Let me name this triangle as ABC, as A, B, and C. So there are two normals. One is at face AB and one is at AC. Now see the ray of light which is following this path inside the prism. When it will come out from this denser to rarer medium, when it will come out from this rarer to denser medium, it will go away from the normal. Away from the normal means it will go away from the normal like this. Okay, it will follow this path. It will follow this path. Now we can clearly see, this angle, this angle. If I'll consider this angle as emergent angle and this one as R2, we can see that R2 is less than E. That means it is going from denser to rarer medium. Okay, fine. Now see, we have seen that this ray of light, this is the incident. Pardon my writing because I am not habitual of writing on the this pen tab. So please bear with me. This is the incident ray which is traveling from name it OM, O to M. After refraction at M, it is following this path. Name it as MN. And following this MN path, when it is getting out of this medium or prism, it is following this, let's say, NL path. Okay. So, in totality, the ray of light has bent two times, first at point M and second at point N. So, this is how the refraction in prism goes. Okay. Now we will learn about few terminologies which is involved in this case of refraction through a prism. This is the prism angle. Here I'll say the prism angle is A. So it is the prism angle, and we are considering equilateral prism. So all the angles will be equal, that is 60 degree. And this is the prism angle. Okay, now see, we have to calculate the deviation angle of this incident ray which has been taken place by this prism. So what is the deviation and how much deviation will be there? We have to calculate by using some formula and some relation. So we'll do that in the next slide. So to calculate the angle of deviation, first I have to take few rays, that is the incident ray. Let me make it quick. Uh, this I'm considering this one as incident ray. This one is normal. After reflection, I'm considering the ray is going bending towards the normal like this. And again, after reflection at this point, let me make a normal again, which will be something like this. I have to place it at proper place here. Okay, now after reflection again at this point, the ray of light will go somewhat like this. Okay. Now, if the incident ray haven't gone through deviation or it has followed its path, then this blue ray or blue line will be its original path. But here what has happened? The actual path is going this way. Okay, this is the actual path. This one. This is the incident ray. This is the emergent ray. And this is the angle by which it has been deviated. Okay, there are a few more things I have to mention here. Let me name it as A, B, C, and the prism angle will be A. So angle A will be the prism angle. Okay, and name this point as M, this as N, this as O. These red lines are normal at these surfaces, surface AB and surface AC. You can see this angle is 90 degree and this angle is also a 90 degree. Now see, the ray of light, if I name it as, let's say, LM is the incident ray. It has to go through this blue line, but it has followed this MN path. So it has deviated at this point M, and I'll consider it as deviation angle 1, delta 1. Now, following this MN path, if further the medium was same, that is denser medium itself, then this ray have followed this path only. This path means this one. This path, let me make it a little thinner. Uh, this path, right? This path. But, but, but it has gone through this path. This as N, let's say name it as NQ. So the ray of light, instead of following the MN and then again the blue path, it has followed through the NQ path. Let me explain it again. See, LM is the ray of light which has to pass through this blue ray of light, this one. But due to the presence of this prism, it has gone to refraction phenomena and followed this MN path. Now, this MN ray of light, if the further medium should be the denser one, then it have followed this blue line path. But because the medium has changed and it has gone, that ray MN has gone through refraction, so it has followed this one path NQ. Now, the actual path of the ray is LMNQ. Now, if I'll see from the initial, it has followed this path if the prism is not there, but it is following this one. So the angle made by these two lines is the angle of deviation. I have represented it with the help of delta, and I am considering the first angle as delta 1, this one as delta 1, and this one as delta 2. Okay, now if I'll extend this white ray of light, this NQ, if I'll extend this ray of light NQ, I'll see if I'll extend this ray of light NQ backwards, I'll see I can draw this delta 2 somewhere here. If I will extend it, then I can write this delta 2 as somewhere here also. See here, delta 2, because delta 2 here and this one is the vertically opposite angle. Okay. Now, so angle of deviation in totality will be equals to the sum of the two angle of deviations that are delta 1 and delta 2. So we have to find the value of delta 1 and delta 2, and we'll put this value in this equation. Let's say consider it as equation 1. So how we are going to do that? Let me minimize this thing. Let me see if it is possible to write. No, okay. We will move it to the next page. We will move to the next slide. Okay. Okay. So in the next slide, we have to write del equals to delta 1 plus delta 2. Going to the previous slide again, if I have to find the value of delta 1, it will be previous one, delta 1. Delta 1 will be equals to how much? So for that, I have to consider this angle of incidence as I, this angle of refraction as R1. Now this angle, this MNO as R2, that will act as an angle of incidence at point N, and this one, the angle between this red line and this white one as angle of emergent angle E. Now we can see that delta 1 plus R1 is I by vertically opposite angle property. So we will see that delta 1 be equals to I1 minus R1. Okay. Now again going to the previous slide, delta 2 will be nothing but delta 2 plus R2 is angle E, right? Again by vertically opposite angle. So delta 2 will be E minus R2. So by putting these two values in the first equation, we can get this one. Delta equals to I1 minus R1 plus E minus R2. And rearranging it, we will get I plus E minus R1 plus R2. Now, because these two refracting angles are the angles inside the prism, we can see these two angles R1 and R2 are the angles inside the prism. So we have to follow, or we have to find the equation in terms of known values. Like we know the prism angle as A, but we don't know the value of R1 and R2, because for different angle of incidence, there will be different R1 and R2. So to find that, if we will see this quadrilateral AMON, we can see this triangle AMO, this angle AMO. In angle AMO, we will see that angle M is 90 degree. Why? Because it is made by this red line, which is 90 degree, placed at a surface AB. So this angle is 90 degree. This angle is 90 degree. And again, we'll see that angle ANO, that is also placed at 90 degree. So in this quadrilateral, which one? Quadrilateral AMON. There are two angles which are 90 and 90 degree. So adding the rest two angles and these two known angles, we will have the value uh, quadrilateral. Let me write quadrilateral. Quadrilateral AMN. It was AMN. Sorry, AMON. So AMON. 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 So in this quadrilateral, the angle A plus angle O plus angle M plus angle N equals to 360, because we know that the sum of all the angles of a quadrilateral triangle, is 360 degree. So this value and this value is nothing but 90 degree and 90 degree. So this will be 180 degree, and we will have the equation angle OA plus angle O is nothing but 180 degree. Now, if I have to write in terms of O and A, we can rearrange this equation as angle O equals to nothing but 180 degree minus angle A. Consider this as another equation, okay, another equation. Now, if we'll go again in that diagram, we will see in triangle MNO, again I am using the highlighter MNO. In MNO, again we know that the sum of the angles of a triangle is 180 degrees. So angle R1 plus R2 and angle O will be equals to 180 degree. So from this relation we can write again an equation that is angle M plus angle N plus angle O. Though I'm not writing it correctly because angle M is something different. I have to mention it angle NMO and angle MNO and angle MON. So just for understanding, I'm writing it in short. So the sum will be 180 degree, and we can again rearrange it. Angle O will be nothing but 180 degree minus this one is R1 and this one is R2. So it will be R1 plus R2. I am skipping one step. I'm just taking the minus common and putting them in the bracket. Now, comparing these two equations, we can see that LHS is equal, that is angle O. So we can equate the RHS. From here we will get 180 degree minus R1 plus R2 is equal to 180 degree minus angle A. See, 180 degree and 180 degree will get cancelled. This minus will also get cancelled. From here, we have found out in the next page, R1 plus R2 is nothing but angle A. And we can see that our equation was for delta, it was I plus E minus R1 plus R2. So in place of R1 plus R2, I can write angle A. So we will have our final equation, delta will be equals to I plus E minus A. This is the final equation for finding the angle of deviation or deviation angle through a prism. So this is all for this video. We will cover the next thing in the next topic, that is the graph made by this equation and what will be the minimum angle of deviation through a prism. Thank you.